So before we look at vectors, there are two kinds of physical quantities. One, we have those which have only magnitude, so we call them scalars. Example, we have length, area, volume, mass, work, energy, distance, speed, and density. You can only measure the volume of a water. The volume of a water, you don't have any direction. That is why they are quantities that have only magnitude. Now, the second type, we have those which have both magnitude and direction. We call them vectors in bracket. Example of vectors, we have displacement, velocity, acceleration, force, and momentum. Now you discover that velocity is defined as change in distance over change in time. So velocity has magnitude and direction. Now, coming to vector notation. In vector notation, we write small a and put a dash under it. Or we write A in bold. Or we have this is capital AB, arrow on top. Or capital BC, arrow on top. So all this representation, we can represent our vectors in this form. Now, looking at the magnitude of vector. So the magnitude of vector is called the modulus. If you can recall your Pythagoras theorem, it's the same thing as modulus of vectors. Now, we have one. That is triangular law of vector addition. Now, in the triangular law of vector addition, once you have a right angle triangle like this, A, B, C. Now, if somebody is at point C and you are at point A, you want to reach him at point C. Now, you may decide to move from point A to C, which is you have AC equals to, but you may also use point A, B, then BC. That is why you have AC is the same thing as from A to B, then B to C. Now, that is why we say, notable, movement from A to C is in two ways. The first approach is to move from A to C, that is AC, which is this. The second movement is to move from A to B, which is AB, A to B, then B to C, which is BC. That is what the triangular law is explaining. Now, later I will tell you something about the triangular law. Now, if you look at it here, since this is a triangular law, in mathematics, if we have 3 equals to 3, now what we are saying is that what you have at the left-hand side equals to the right-hand side. Now, if you look at this, if this is AB plus BC, B will go with B. It's still giving you AC. So that means it's like 3 equals to 3. So in this case, since AB equals AC equals AB plus BC, so it's the same thing as AC equals AC. Now let's look at 2, which is parallelogram law of vector addition. Now, the law states that the resultant of two vectors is represented by the diagonal of the parallelogram. If this is a parallelogram, I have a parallelogram here. P, Q, R, S is a parallelogram. PS is parallel to QR. PS is equal to QR. PQ is parallel to SR. PQ is equal to SR. Now, if this is 7, this will be 7 centimeter. If this is 5 centimeter, this is 5 centimeter. Based on the properties of a parallelogram. But what a parallelogram law is saying is that the resultant of this parallelogram is given by this diagonal PR. That is just what the law is saying. Now, you have PQ, vector PQ plus vector PS equals to vector PQ plus vector QR equals to PR, vector PR. How? PQ here is 5 plus PQ here is 5 plus PS. PS is 7. 5 plus 7 will give you 12. It's the same thing as PQ. PQ, which is 5, plus QR. QR is also 7. So 5 plus 7 is 12. So it's the same thing. That is what we are saying. Now, PR, which is PR, is the diagonal. This is the diagonal of the parallelogram, and which is the resultant. Now you take note of this. Take note of this. We have vector PQ plus vector QR equals to PR. How? Q can go with Q. You are left with PR. You are left with vector PR. Now vector PR plus vector RS. R can go with R. You are left with PS. Now vector PS plus vector ST. S can go with S. You are left with vector PT. Now this is what we call, hence, polygons of vectors. We have PQ, vector PQ plus vector QR plus vector RS plus vector ST equals vector PT. How? Now if you look at it, this is PQ plus QR, which is this. PQ plus PR. Now you find out that Q can go with Q. Q can cancel Q. You are left with PR instead of this. Then RS plus ST. You have like terms there. So RS plus ST. S can go with S. You are left with RT. Now, this result, which is this, is PR. This is PR here. PR. Plus this result is RT. That is why you have RT here. R go with R, so you are left with PT. That is giving you vector PT. Now, note very well, vector PQ plus vector QR is the same thing as PR. How? Q cancel Q, so you are left with PR. Vector RS plus vector ST, S go with S, so you are left with RT. Now, we have resolution of vectors. Resultant of vectors. Now, in resultant of vectors, we are referring to the sum or total. Now, resultant of vectors. Resultant of vectors is the sum or the total. Now, there are some steps here that you can use if you want to solve a resultant of vectors. The first step is add the given vectors. The second step, you collect like terms, e.g., like I have vector SR and vector RT. They are like terms. Then, notable, if you have negative BC, that is vector BC negative, is the same thing as vector CB positive. You change the position. Minus FT, that is minus vector FT, is the same thing as positive vector TF. 4. There are situations where you can split. In this case, I have 3BT. I can split it into 2BT plus BT. It's just like if you have 3x, you can split it to 2x plus x. That is what I'm trying to explain. Now, let's have an example and see how we are supposed to solve problems in resolution of. Now, illustration. Find the resultant of the vectors AC, 3BC, CD, 3CD, and DA. You have to find the resultant. Now, based on the steps I outlined there, first, this is solution. Then you now add AC plus 3BC plus CD plus 3CD plus DA. Now, this is a first line. You can see it here, first line. Now, you now collect like terms. Now, we have, if you look at AC and CD, they are like terms. That is why I have it here, AC plus CD. C cancels C, you are left with AD. That is giving you 1. Then you have another like terms, 3BC, 3CD. 3BC, 3CD. 3 is constant, so you factor it out. 3 into BC plus CD. You find out that BC and CD are like terms. C cancels C, you are left with BD. That is why we have 3BD, 2. Then you now come back. In place of AC plus CD, we are going to have AD because we have AD here. in place of 3BC plus 3CD, we are going to have 3BD, what we have here, plus DA. Now, this is the second line. Now, in the second line, you now split this. This is 3BD. Instead of 3BD, you write it as 2BD plus BD. 2BD plus BD is 3BD. So we now replace this. So this is AD plus, in place of 3BD, we have 2BD plus BD plus DA. Now, this is the third line. This is our third line. Now, from the third line, we have like terms here. Now, if you look at the like terms here, these are the like terms. So you collect like terms. So we have BD plus DA, which is this. BD plus DA. D cancel D. This is giving you BA. This is BA. Now, you now have AD plus 2BD. In place of this, is giving us BA. So this is our fourth line. Our fourth line. So you collect like terms. Now, if you look at it, you have to be very careful at this stage. Instead of AD plus BA, it's better you write it as BA. BA plus AD. Now, BA plus AD, A cancel A, you are left with BD. That is giving you BD. 4. Now, in place of AD, in place of BA plus AD, you now replace it with BD. That is why we have BD here. So, BD plus 2BD. BD plus 2BD is giving us 3BD. So, this is the final solution. Now, let's look at another example. We have illustration here. Find the resultant of the vectors BC, vector BC, comma, minus vector DC, and minus vector DFD. Now, solution, the steps, we are to add the given vectors. We have BC plus, you open bracket, minus vector DC plus, open bracket, minus vector FD. Now, if you open this bracket, this is BC, plus minus is minus, so vector BC minus vector DC, plus minus is minus, minus vector FD. Now, take note of something here. Instead of vector minus DC, is the same thing as CD, positive. That is why here we have CD instead of minus DC. The same thing applies here. Instead of minus FD, is the same thing as DF, positive. So we have plus DF here. Now, BC plus CD here, this will go with this. You are left with BD plus DF. Then at this stage, D will also go with D. You are left with BF. So our solution is BF. So the resultant of this is BF. Now, this is an exercise for you. Find a resultant of FD, DA minus CF and CA. You have to find the resultant of these vectors. Now, I've given you the answer here. The answer is 2FA. So, you try it. For any contact, you can reach me at 070 3813 9353. Thanks for listening. Remain blessed.